Lesson 5.1 is about parallelograms. The definition of a quadrilateral is, the definition of a parallelogram is that it's a quadrilateral with both pairs of opposite sides parallel. So if I use two little arrows to denote those two sides are parallel to each other, and then these other two sides, opposite sides, are parallel to each other. That's a parallelogram. Okay, there are three properties about parallelograms that you need to know, and they're all stated as theorems. And the first one is that the opposite sides of the parallelogram are not only parallel, but they are congruent to each other. So we can see these two sides would be congruent to each other, and that pair of opposite sides would be congruent to each other. The second thing is that opposite angles of a parallelogram are congruent to each other. So this angle would be congruent to this one, and this angle congruent to this one. And then the third thing you need to know is that the diagonals bisect each other. So what does that mean? Well, if we sketch in two diagonals here, from vertex to vertex going across the parallelogram, it turns out that, they may not be the same length, the green segments, but they bisect each other, so they cut each other into two congruent segments. So those two pieces are the same length, and these two pieces are the same length. So they bisect each other, those diagonals. So those are the three properties that you need to know. So here's a proof of those three properties, which I think it's always important to understand why things work. So this is a parallelogram. It's given. So I'm going to take one diagonal and divide this parallelogram into two triangles. And if I can prove these two triangles are congruent, I can prove all their parts are congruent, and that'll get me to proving the properties. So I know, say, this leg or this side is parallel to this side, and this side to this side. So if the left and right side are parallel, then I know that these two angles here, this angle and this angle, are congruent because those are alternate interior angles, because the green segment represents a transversal. So those two are the same. Then if I know that the top side and the bottom side are parallel, if I look at the angles that they're touching, I know that this angle here must be congruent to this angle here. Okay, and then I look at the side in the middle and I think, oh, well, that's the same, that's a common side, that's congruent to itself by reflexive property. So I have the top triangle congruent to the bottom triangle by angle side angle. Okay, once I have those two triangles congruent by angle side angle, I know all their other corresponding parts are congruent. So I can now say without a doubt that, let's do these in green. I can say that I know that this side across from the double swooshed angle is congruent to this side across from the double swooshed angle. And I know that, well, let's do those with 3. Okay, and then I know that this side up here is congruent to this side on the bottom. And I also know that these third angles are congruent, the third angle of each triangle. So I have opposite sides congruent. The total of these two opposite angles are congruent because they're both the sum of the blue and a purple. These opposite angles are congruent. And we'll get to why the diagonals bisect each other in a later lesson. But anyway, this is why parallelograms have all of the congruences. So let's do a few examples to apply these concepts. Okay, in each of these examples, the given figure, the quadrilateral, is a parallelogram. So I won't show the parallel markers on the sides, but they are all parallelograms. So we've got to find the angle measures of x, y, and z. So the first thing I'll do is I'm going to look, and easily I can find y, because I know opposite angles are congruent. So y is 65 degrees. And then I can see that y and x, if there are long parallel lines here, if I trace these two, those are alternate interior angles. So x is the same as y. So x is 65 degrees. And then I know that if the top and the bottom are parallel, that these two here are same side interior angles and have to add to 180. So if I have 165 on the bottom, then z is equal to 180 minus 65 degrees, or 115 degrees. Okay, in this next parallelogram, again, I'm finding angle measures for x, y, and z. So first of all, I can see that x and the 110 degree angle are vertical angles, so x is 110 degrees. I also see that if I've got parallel sides here, that this 70 degree angle is an alternate interior angle with z, so those are the congruent. So z is 70 degrees, and that should allow me to find y. I can see along the straight line, either looking at angle x or the 110 degree angle, that along that straight line, these have to add to 180, these two right here. So I know that this has got to be 70. And if I have those two 70 degree angles, that actually makes that little triangle isosceles. Those add to 140, so y has to be 40 degrees. Okay, in this next example, I have a parallelogram where I've got to find some sides and segments and some angles. So A and B will be sides and segments, and x and y will be angle measures. So let's look at the sides and segments first. Because I know that opposite sides of a parallelogram are congruent, I know this side of 8 is the same as this side, so I know that B is 8. And because diagonals bisect each other, I know that this segment here is the same as this segment here, so A is also 8. And now I'm ready to move on to angles. So let's mark everything I know. I can see that I've got vertical angle for x in the middle. And let's see, let's look at y. Well, let me see, let's take a look. Well, first of all, maybe we'll come down here and look at, trace that 56 degree angle is going to be the same as this one. So we'll fill in what we can here. And this 26 degree angle is alternate interior. That'll be the same as this one. And maybe that helps us a little. So I'm looking at the x and the y, and what I have to focus on is everything that I learned so far I'm responsible for applying. And I know that I've got a triangle here with a side of 8 and with this other side of 8. If I look at this triangle right here. And that's an isosceles triangle. And that means that the base angles are congruent. So actually these sides are the same length, so I can now, I'll put doubles on those, so all those pieces are 8. Anyway, I have an isosceles triangle, so I know now that this angle opposite one of the congruent sides is the same measure as this angle. So x is equal to 56 degrees. Okay, now y is going to fall out because the two 56s have a sum of 102. So I know that y is 180 minus the 102, or the other 68 degrees. And that's it for applying the concepts, the basic properties of parallelograms.